Hi, welcome back to our discussion of contours. You might recall from our last video, we said contour is basically a three-dimensional representation on a two-dimensional plane. So here we have corn production, that's P. So the contours on this line represent the amount of corn produced. No units, they're just corn produced as a function of rain and temperature. So we're saying the corn production is a function of rain and temperature. And if you notice here, along the x-axis, that's the amount of rain, and on the y-axis, we have our temperature in degrees. Whoops, not Celsius, but Fahrenheit. Whoops, mathematicians, units, go figure, right? All right, so at the point that we're present here, so at the point right here, so if we let P, in this case, at our point present, so we're going to use this point present, at P, my x value is 15, so the amount of rain is 15. The temperature is 76. They are telling us that the amount of corn being produced is 100. So that's really what these productions that's what this contours describe for us. They tell us what is being produced given x and y. So everything along this contour will give us a production of 100. A rain of 18 and a temperature of maybe 71 degrees, so on and so forth. So let's see what they're kind of asking for. So let's apply some calculus here. The very first question, it says, what is the change in P production with respect to R? Now remember, they're talking about partials here because we got multiple variables here. But the idea behind calculus is still the same. This is asking how does the change in rain affect the production? And that's what this question is asking. How does our change in rain affect production? And we can answer that really easily by looking at the change in production. This is just a change. This is AROC, basically. Average rate of change. So if I'm at my present point and I increase, we're always going to go to the right. Just go for consistency. Let's always go to the right. We're going to increase our values. We want to know if we increase something, how is it going to change? So let's see. My change in production, well, let's take a look here. I started at 100. Now I'm at 110. So my change in production, we're going to take the final minus the initial, 110 minus 100. Well, how much did my rain change by? Now remember, we went only along the x-axis. We're not interested in how the temperature affects it, just the rain. So temperature, its derivative is 0. So there's no change up there. That's why we're using this horizontal line along parallel to the x-axis. So now I want to change in rain. Well, my rain started at 15, now it's 18. So final minus the initial, 15 minus 18. And that's going to give us 10/3. Well, let's take a look at the units here. Production. Let's say that's tons. Okay, I'm just going to make up a unit. They didn't tell us. So that's tons per inch of rain, let's say. Per rain, whatever unit. So what's going to happen is, how does a change in rain affect it? Well, it affects it by 10/3 tons per inch of rain, or something along those lines. So this is increasing for us. Let's see if we can try the next one. The change of how does temperature affect production? Well, in this case right here, now we're not worried about the amount of rain, just temperature. So we go up. So from my present point, I'm going to go up until I come to the next contour. Well, I'm looking still for the change in production. So I'm going to go from final minus the initial. Well, notice my initial now is at 90 minus my initial, which was 100. Divide that by the change in temperature. Well, my final temperature was at 78 degrees minus the 76 degrees. That was my initial temperature. And that's going to give us -5. And that's going to give us -5 tons per degree Fahrenheit. So as temperature increases, what happens to our production? It lowers. Remember, what this is asking, how does temperature, the change in temperature, affect production? And if you notice, if temperature increases, we get less production. Those darn global scientists, they're wrong. I know they're wrong. All right. So the last question, this is just more how does estimate the change in temperature with respect to the change in rain. So that's not terribly bad to do. If I'm at this point right here, this is just my change. If I'm going, remember, we always want to do the increasing. So my change in temperature, well, my change in temperature was at 78 minus 76 over my change in rain, which was 18 minus 15. And if we simplify this, we get 2/3 degree Fahrenheit per inch. I don't know how that affects production thing, just kind of something else we can do mathematically there. All right, now the last question right here, part D, this is going to be how we kind of apply this to predict future models. We can model future production, predictions in production. Predictions in production. There, I think I got it out right that time. All right, so next year, we are predicting a 1/2 inch less of rain. Well, what's that going to affect for us? Well, that's my change in rain. So that's my change in rain, dr. And the temperature to increase by 1 degree. This affects my change in temperature, dt. How will this affect corn production for next year? So we are looking for dp. That's what we want to find. So this is an application of the total derivative. We want to find the change in production. So to do this, we're going to use the total derivative, which is very similar to our tangent line approximation, which we've talked about before. In fact, they're really the same. So the change in production is going to be modeled by our rate of change with respect to rain, dr, plus the partial with respect to temperature, dt. And I can just plug these numbers in. dp is, well, my change in production with respect to rain. We already know that up here is 10/3. Well, dr plus my change in production with respect to temperature, we said was -5, so -5 dt. Now the only thing we need now is dr dt, and we actually do have those. The change in rain, a 1/2 inch less, so that's going to become -1/2, and the change in temperature, they're increasing that to be expected to increase by 1 degree. So if I can plug those in, we would get 10/3 dr -1/2 -5 dt becomes -1. Oops, sorry, +1 there. Sorry, it was +1. And if we simplify that, we're going to get -10/3, 20/3. Sorry about that. So what is this telling us? Yeah, the production. We should expect the production of corn to decrease for next year. All right, so the last one we're going to take a look here for part 1 is label the point A on the production at 100. So on the production contour of 100, where the change in rain is 0. Production over the change in rain is 0. Remember, so therefore R is not changing. So the only way this can go is up or down. This it cannot go. It can only go up or down. Rain is not changing. So there's no change in R. And that's what they're saying here, dp dt is increasing, right? So this is increasing, so it has to go up. The only way, so production has to increase with respect to temperature. The only way that can do is go up. So the only place I can put that on this point all the way down here is somewhere down here at the very bottom, somewhere down here. We'll call that point A, right there. Because the only way it can do is it can go up, because there's no change in R. All right, so go to video 3. We'll take a look at another example, and I'll see you then. Bye-bye.